Hi student, this is Sivakumar. 11th Standard Business Mathematics and Statistics, chapter number 2, continuation of exercise 2.4. Now problem number 7. There are 18 guests at a dinner party. They have to sit 9 guests on either side of a long table. 3 particular persons decide to sit on one particular side and 2 others on the other side. In how many ways can the guest to be seated? Look at the diagram. There is a dining table. Either side of the dining table, here 9 guests, totally 18 guests to be seated. I consider them as side 1 and side 2. Side 1, totally 9 seats. So 9 guests can be seated. Even in side 2, we have 9 seats. Automatically 9 guests can be seated. Okay. 2 conditions are given. The condition number 1 is 3 particular persons, 3 guests, they want to sit particular on any one of the sides. I consider as side number 1. In side number 1, 3 particular guests want to sit, and two more guests, they want to sit on the other side, that is side number 2. Again I tell you, 3 particular persons want to sit on one side, I consider as side number 1, and 2 more persons want to sit on the other side, that is side number 2. Okay, I write here by data 3 persons particular persons, or you can write guest, can be seated in side number 1, and 2 particular persons or guest can be seated on the other side, on the other side, that is side number 2. Okay, therefore the remaining guest to be seated equals total number of guests 18 minus one side 3 particular persons will be seated, and other side 2 particular persons will be seated, so both to be added. So 18 minus 5, that is a 13. Okay, therefore the total number of arrangements that is equal to, for the arrangement first you have to select the persons, after that we have to do the arrangement. Okay, children, listen. Here I consider either side 1 or side 2. I go for side 1. In side 1, already 3 particular persons want to sit in side number 1. Yes, the remaining how many seats will be vacant? Here totally 9. 9 minus 3, that is equal to 6. Yes, 6 seats will be vacant. Here we have 13 guests more. So the total number of arrangements, that is equal to, first we have to select, so 13 C6. Either 13C6 or 13C7 you have to consider. Once you make that selection for the 6 members, automatically the remaining guest will be seated on other side. Yes, You can go for side 2 also. Side 2, already 2 persons want to sit in particular side number 2. So how many seats are vacant? 7 seats are vacant. Yes, we have 13 guests are there. So 13C7. At the same time, 13C6 and 13C7 are same, you know very well, because NCR that is equal to NCN minus R. So either 13C6 or 13C7 you have tried. Then once the selection is over, then you have to do the arrangement. What to do for that? Into, remember, here 9 guests have been selected. Here also we have selected 9 guests. They have to be arranged. For that, what to do? So the 9 guests can be arranged in 9 factorial ways. 9 factorial ways. So 9p9. That means 9 factorial. So already told you that for arrangement you have to apply the permutation. So you have to put 9p9 ways for side 1. Like that, here also we have 9 guests. They have to be arranged. Here also you have to apply that permutation. Again 9p9. 9p9. That is a total arrangement. Then we have to simplify. We have to do the calculation. Listen, 13C6. That is, we can apply that formula NCR. NCR, you know that NCR, that is factorial n divided by factorial r into factorial n minus r. N that is equal to 13 and r that is equal to 6. If you substitute, you'll be getting 13 factorial divided by 6 factorial into n minus r, 13 minus 6. 13 minus 6 that is equal to 7 factorial into npn, you know, npn that is equal to factorial n. Yes, so 9p9 that is 9 factorial. Again you have to put 9 factorial. That's all. That is a total number of arrangements. You no need to do that further calculation because it's a bigger value indeed, 13 factorial, 9 factorial and all. So no need to multiply. So you can stop the answer at this stage. Definitely will be given the book full mark. Even the book answer is the same. So problem number 7 is completed. Now I'll be doing problem number 8. Problem number 8. If a polygon has 44 diagonals, find the number of its sides. See what is given? Number of diagonals of a polygon having n sides, that is equal to 44. Children, there is a formula for finding the number of diagonals of a polygon, that is NC2 minus n. Remember, NC2 minus n. Here n represents a number of vertices or number of sides. Number of vertices and number of sides are same only. Then 2 represents 2 vertices are needed for constructing a line segment, right? NC2 minus n, that is equal to 44. From this equation I am going to find out the value of n. That n refers number of sides. Okay, how to find? Children, you know that NC2 can be written as n into n minus 1 divided by 2 factorial, that is 2 into 1, because starts with n, reduce 1 in n, so you'll be getting n minus 1. So only 2 terms in the numerator because the value of r is 2. Divided by, since the value of r is 2, you have tried 2 factorial in the denominator, 2 into 1, minus n, that is equal to 44. Okay, now I multiply these two, n into n squared minus n into 1 n minus 2 ones are 2, then you have to multiply these two, 2 ones are 2 into n, that is 2n, whole divided by 2, whole divided by 2, that is equal to 44. Just I have taken the LCM, LCM is 2 only. Even you can put 1 over here, 1 into 2, that is 2 here. Good. Then n squared minus n minus 2n, that is minus 3n, that is equal to, you have to cross multiply, this is 2 only, 2 into 44, that is 88. You have to cross multiply. Okay, then n squared minus 3n, this plus 88 comes to the left hand side of equal sign, it becomes minus 88, that is equal to 0. Children, it is a quadratic equation. It can be solved. We can go for that splitting the middle terms. 1, the coefficient of n square is 1. That 1 should be multiplied with the constant minus 88. 1 into minus 88 is minus 88. And the coefficient of n, that is equal to minus 3. Product minus 88 and the sum minus 3, the two numbers are 11 and 8. Yes, minus 11 and plus 8. Minus 11 plus 8, that is equal to minus 3, and product of the two numbers, that is equal to minus 88. Yes, for finding the values of n directly, consider the coefficient of n square, that is 1. You have to change the sign and 1 becomes minus 1 right in the denominators of both the numbers. Then it can simplify, minus minus get cancelled. Yes, 11 by 1, that is equal to 11. 11 by 1, that is equal to 11, and n, that is equal to 8 by minus 1, that is equal to 8, minus 8. Here n represents a number of sides that cannot be negative, so not possible. At the same time, NCR and NPR, n cannot be negative, remember. So I got the value of n, that is equal to 11. You are asked to find out the number of sides only, that is 11. You write the result at the end. Therefore, number of sides of a polygon having 44 diagonals, that is equal to 11. Problem number 8 is completed. Now I'll be teaching problem number 9. Problem number 9, in how many ways can a cricket team of 11 players be chosen out of a batch of 15 players? Three subdivisions are there. The first one is there is no restriction on the selection. Second one, a particular player is always chosen. And the third one is a particular player is never chosen. Right. First, we can do the subdivision number 1. What is given? There is no restriction on the selection. Since there is no restriction on the selection, all the 11 players for a cricket team to be selected from the total number of players, 15 given. So from the 15 players, it is only selection, so you have to write 15C11. Okay, that is equal to 15C11 can be written as 15C 15 minus 11, because NCR, that is equal to NC n minus R. There is a property. I have applied the property. So 15C 15 minus 11, that is equal to 4. Now we can find the calculation. We can do the calculation. You start with the 15, keep on reducing 1. 15 becomes 14, 14 becomes 13, 13 becomes 12. Only 4 numbers in the numerator because the value of R is 4. Divided by 4 factorial. That is 4 into 3 into 2 into 1. We can cancel by 4 table, that is 3 times and 3 get cancelled, and 2 table we can cancel by 7 times. That is equal to 15 into 7 into 13, that is equal to 91. We have to do that calculation. 15 into 91, I write here 15 into 91. 1 into 15, 15, 9 5s are 45, balance 4, 9 1s are 9 plus 4, that is 13, equals 5, 6, 3, 1. So 1365. Total number of ways, that is 1000 365. Subdivision 1 is completed. Now I do subdivision number 2. Look at the second subdivision. A particular player is always chosen. Okay. Since a particular person is always chosen, the remaining 10 more players for a team, because already we have selected one person, so 1 plus 10, that is 11, because a cricket team has 11 members, correct? 10 more players for a team to be selected from the remaining 14 players. Why have taken that 14 players? Because out of 15 players, one has been selected always. So we have only 14 members. So out of 14 in 14C 10 ways. 14C 10 ways. Here also I have tried in 15C 11 ways. So 15C 11, that is 15C 15 minus 11 according to that property. Good. Then now 14C 10. You have to do the calculation. Therefore 14C 10, that is equal to 14C 14 minus 10. The same property, since NCR, that is equal to NC n minus R. Okay. Then 14C 14 minus 10, that is equal to 4. 14C 4 can be written as 14 into 13 into 12 into 11 divided by 4 factorial. 4 into 3 into 2 into 1. We have 4 numbers in the numerator because the value of R is 4. At the same time, 4 factorial in the denominator. Now we can simplify 4 table 3 times, 3 get cancelled, 2 table 7 times. That is equal to 7 into 13, that is equal to 91 into 11. 91 into 11, that is equal to 91 again 91 1 0 10, that is 1001. Now subdivision number 3. Subdivision number 3, a particular person is never chosen. Since a particular person is never chosen, so all the 11 members of a cricket team to be selected from the remaining 14 players. Why I have taken 14 players? Because one person is never chosen. So we have only 14 members. 15 minus 1, that is 14 members. From 14 members, 11 members to be selected for a cricket team. In how many ways? 14C 11 ways. Okay. Now I have to do the calculation for 14C11. Therefore, 14C11 that is equal to 14C or 14 minus 11. So what form it is? NCR. NCR that is equal to NC n minus R, that is 14 minus 11. I write the property again, since NCR that is equal to NC n minus R. That is equal to 14C, 14 minus 11 is 3, 14C3. You know how to write 14C3? Start with the 14, keep on reducing 1, 14 becomes 13, 13 becomes 12, only 3 numbers in the numerator because the value of R is 3. At the same time, 3 factorial in the denominator. 3 factorial in the denominator, that is 3 into 2 into 1. Now we can do that simplification. 3 table 4 times, and here we have 2 table 2 times. That is equal to 14 into 13 into 2, that is 26, equals 14 into 26. I do the calculation here. 14 into 26, 6 4s are 24, balance 2, 6 1s are 6 plus 2, 8, and 2 into 14, that is equal to 28. That is 364. That is the answer. That's all. Problem number 9 also completed. Then I'll be teaching the last problem, that is problem number 10. Problem number 10. A committee of 5 is to be formed out of 6 gents and 4 ladies. In how many ways this can be done when at least 2 ladies are included? At most 2 ladies are included. 2 subdivisions are there. We can do one by one. So remember, we have 6 gents and 4 ladies. A 5 members committee to be formed. 2 conditions are there. First one, at least 2 ladies are included. Next one, at most 2 ladies are included. Look at that. We have a number of gents that is equal to 6, number of ladies that is equal to 4, a number of members in a committee equals 5. Okay. Yes, gents we have 6, ladies 4. Condition, first condition, at least 2 ladies to be selected. At least 2 means minimum 2 ladies. Suppose I select 2 ladies, definitely 3 gents to be selected. Then only can get 5 members for a committee. 2 plus 3, that is equal to 5. Suppose I select 3 ladies, definitely only 2 gents to be selected. 3 plus 2, that is equal to 5. Suppose I select all 4 ladies, maximum you can go 4 because we have 4 ladies only. 4 ladies only, 1 gent can be selected. 4 plus 1, that is equal to 5. The combination is, out of 6 we are selecting 3, means 6C3 have tried. 6C3 into, because 3 ladies and 3 gents and 2 ladies. So and here into represents and, multiplication represents and. Okay. 2 ladies to be selected out of 4. So you have tried 4C2. That is equal to, next one 6C2, 6C2 and 3, here we have 4 ladies of 4C3. Finally, only 1 gent to be selected out of 6, so 6C1 into all the 4 ladies to be selected from the 4 ladies, 4C4. That is equal to 6C3. The value is 6C3 equals 6 into 5 into 4, because the value of R is 3, and 3 factorial in the denominator. Yes, that is equal to, you can cancel 3 table, how many times? 2 times, so 2 get cancelled, that is equal to 20. The next one is 4C2. 4C2 that is equal to 4 into 3 divided by 2 into 1. You can cancel by 2 table, that is 2 3s are 6. Next one is 6C2. 6C2 that is equal to 6 into 5 divided by 2 into 1 can cancel by 2 table, that is 3, 3 5s are 15. Next one 4c3. 4c3 equals 4c3 equals 4 into 3 into 2 divided by 3 into 2 into 1. 3 3 2 2 get cancelled, that is equal to 4. Then 6c1 and 4c4. 6c1 that is equal to 6c1 that is equal to 6 because nc1 is n, and 4c4 that is equal to 1 because ncn is 1. Now we have to substitute. 6c3 that is equal to 20. 20 into 4c2 that is equal to 6. 20 into 6 that is equal to 120. 6c2 that is equal to 15. 15 and 4c3 that is equal to 4. 15 into 4 that is equal to 60. 6c1 that is equal to 6 and 4c4 that is equal to 1, that is equal to 6. Then you have tried the total combination. The total combination 120 plus 60 plus 6 that is equal to 186. That's a total combination. This is for the first subdivision. For the second subdivision, condition number 2, what is given? No, maximum, at most 2 ladies can be selected. At most 2 ladies means maximum we can select 2 ladies. If you select 2 ladies, 3 gents can be selected. 2 plus 3 that is 5. If you select only 1 lady, you can go for 4 gents. 1 plus 4 that is 5. If no lady is selected, you have to go for 5 gents. 0 plus 5 that is equal to 5. Total should be always 5 only. You know the combinations, we have 6 gents and 4 ladies, correct? I write here 6 gents and 4 ladies totally. 6 and 4. The combination is 6c3 into 4c2. 6c3 into 4c2. Then 6c4 into 4c1. 6c4 into 4c1. Finally 6c5 into 4c0. 6c5 into 4c0 equals 6c3 equals 6c3 equals 6 into 5 into 4 divided by 3 into 2 into 1. Can cancel by 3 table, that is 2 times 2 2 get cancelled, that is equal to 20. Next one 4c2. 4c2 that is 4c2. 4 into 3 divided by 2 into 1. Can cancel by 2 table, 2 3s are 6. Then 6c4. 6c4 that is equal to 6 into 5 into 4 into 3 divided by 4 factorial. 4 into 3 into 2 into 1. We can cancel 4 4 3 3 and 2 table. How many times? 3 times. 3 5s are 15. Then 4c1. 4c1 that is equal to 4. Yes, nc1 is n. Then 6c5 that is equal to 6c5 that is equal to 6c6 minus 5 because ncr equal to ncn minus r. That is 6c1. 6 minus 5 that is equal to 1. 6c1 that is equal to 6 because nc1 is n. Finally 4c0. 4c0 that is equal to 1 only because nc0 is 1. Now you write a 6c3 value, 6c3 that is equal to 20, 4c2 equal to 6. 20 into 6. 6c4 and 4c1 that is 15 and 4. 15 and 4. Finally 6c5 that is 6, 4c0 is 1. 6 into 1. that is equal to 20 into 6, that is 120, 15 into 4, that is 60, 6 ones are 6, together 186. The total combination is that is equal to 186. Subdivision 1 and subdivision 2, same answer, 186 ways. Is problem number 10 also completed? Okay. Children, I have completed exercise 2.4. Then I'll be taking that next exercise in the next video. Thank you, children.